In lesson 72, we will learn what it means to have a negative angle, and we will also review converting back to polar. From now on, when you add vectors, we are going to expect you to have the rectangular answer because that's the only way you can add vectors, and we are going to expect you to also have the polar form, so you will need to convert back to polar. So first, positive and negative angles. We have learned that if we have positive angles, we have our axes, we start from the positive x-axis, and we go around in the counterclockwise direction. If we have negative angles, we are now simply going to go in the opposite direction. So we will now go clockwise as we go around the circle. So it may help you to think of it if you have a number line, positive goes one direction, negative goes the other direction. If you have vectors, positive goes one direction, negative goes the other direction. That is all that the minus sign accomplishes. So let's start off with our first one. If we have a negative 30 degrees and we want to draw that vector, we draw our axes for I hat and j hat, and now we're going to go in the negative direction, 30 degrees, so we are about right here. This is 30 degrees right there, and the length of it is 5 units long. And then we could figure out our I hat and our j hat if we wanted to, with those being positive and then negative. So let's take this one and actually do the whole conversion. Wanted to get something that was not just an acute angle 30 degrees, so we could review the reference angle part of that. So we begin by drawing our axes. We are now going to go in the negative direction. So I start out going this way, I get down here, that's negative 90, I get over here, that's negative 180, I get up to the top, that's negative 270, I have to keep going, and so I'm going to end up about right here where that is 5 units long, and as I took my angle all the way around here, that was 320 degrees. Since I know I have ended up in the first quadrant, I know I am ending up positive, positive for my I hat and my j hat. It is not okay in this course to punch negative 320 in on the calculator for the degrees, so we need to figure out if we draw a regular right triangle with the I hat and j hat that we're looking for, how big is the angle in the triangle? As I look at my picture, I see that 320 took me most of the way around the circle, and if I added rho to that, I would have a total of 360 degrees. That is how I know that rho has to be 40 degrees inside of that triangle. So I'm going to use plus plus, and then I'm going to do what I have already learned with converting to rectangular. The I hat part is the magnitude 5 times the cosine of the reference angle, and the j hat part is 5 times the sine of that reference angle. And because I know from my required picture you must draw the sketch, I end up in first quadrant. Both of those need to be positive. So then all you need to do is punch in on the calculator, and you should have 3.830 rounding to 3 places for I hat, plus 3.214 when we round to 3 places for the j hat. So to finish up this lesson, let's do one where we are adding. One's going to have a negative angle, one's going to be a regular positive angle. Let's add them, and let's convert back to polar when we are finished. So we need to begin with these two. We will draw a separate sketch for each. 4 at negative 55 simply means we go in the negative direction for the angle. So we are ending up in Q4, which means positive negative. This needs to be 4 long, and this angle needs to be 55 degrees. So for that one, I can do 4 cosine 55 degrees for the I hat, and 4 sine 55 degrees for the j hat, except that my I hat needs to be positive and my j hat needs to be negative. Then I'm going to do the second one. This time I need to go in the positive direction, 227 degrees. So up at the top is 180, up at the top is 90, over on the left is 180, down at the bottom would be 270, that is too far. So I need to go somewhere about here, and it needs to be longer than that first vector. This one is 7, the first one was only 4. And so now I've got my I hat and my j hat here, and I need to figure out how big that angle is. So if I went all the way around to it, I needed to go 180, that's not far enough, and then my reference angle. So for this one, 180 plus my reference angle needs to be the 227 where I end up. So that lets me know that my reference angle needs to be 47 degrees. So when I put all of this together, I need to, and this quadrant is negative, negative. So for this one, I am going to have 7 cosine 47 degrees for the I hat, and 7 sine 47 degrees for the j hat. Because I wound up in quadrant 3, I need both of those to be negative. So the way that I am going to actually enter that on my calculator, I'll erase these I hat and j hats and put them really at the end of each part. So what I am really entering on my calculator will be a positive 4 cosine 55 minus 7 cosine 47 to have my I hat, and then I will do a negative 4 sine 55 minus sine 47, and that will be my j hat. And if I put all of that together, I should end up with negative 2.480 for the I hat and negative 8.396 for the j hat. That ended up negative, negative, which is quadrant 3. So let's draw my picture with everything all together on it. I should have, if I go 4 at the negative 55 degrees, and then from the second one, so from the end of that, I need to go towards the third quadrant, and I need to go longer than that, so something about like that. So my final one where I end up goes from the origin to that ending point, and that does indeed look like a Q3 vector. Now to convert back. Now what I need to know is this positive angle all the way around to my vector, to my final vector in the third quadrant. So to do that, I need this reference angle piece so I can figure out how to actually write that. So I have my j hat is the negative 8.396, and my I hat is the negative 2.480. What you really need to do as you enter these on your calculator is 4 cosine 55 degrees minus 7 cosine 47 degrees. Store that as I hat. The minus 4 sine 55 minus 7 sine 47 we need to store as j hat. so that once we have these, and we're not going to worry about the minus signs on these, to get the angle, we need the inverse tangent of that stored j over the stored I. I often put boxes around my stored ones just to help me remember where I get those. This needs to be my reference angle. If you have stored those, you may not store negative 2.480. That's been rounded. You have to store all of the digits in there. So once you do that and enter this, we get a 73.546. And you may want to store that as some other variable, p, or since p looks kind of like a row. If you're not sure, you can do the adding by mental math. If you have a negative sign on your calculator, you always want to ignore that. Never write down that row is negative. Row is always positive. To get the magnitude of that, that's just going to be Pythagorean theorem for this red vector. So the magnitude needs to be the square root of our stored I hat squared plus our stored j hat squared. So you simply punch that in on the calculator like you did before. And in this case, that should give you 8.755. So you may write down your final answer is approximately 8.755 at. But our angle isn't 73 degrees when we go all the way around here. Our angle needs to be 180 plus our reference angle to get this one that we really want, which starts at the positive x or I hat axis and goes all the way around to where we end up. So our real angle for this problem needs to be 180 plus the reference angle. 180 plus that 73.546 will give us 253.546 degrees, and that is our final answer. So if you have negative angles, you go in the negative direction. You figure out where you are, you draw your vectors and your triangles and work the problem. If you are adding, you add them, you get the rectangular forms, and you store those I hats and j hats, so you have all of the places without rounding. Then you use those stored I hats and j hats to get the angle, inverse tangent, j hat over I hat, and to get the length of the vector, it is the square root of the stored I hat squared plus the stored j hat squared.